It might seem like more of a magic trick than real science, but physicists have successfully made a cloud of atoms exist in two separate places at the same time. The laws of standard physics dictate an object can't be in two places at once, but the researchers have exploited a quirk of tiny particles that exist in the quantum world, and applied this to atoms. Their breakthrough raises the prospect of being able to send not just information but perhaps even recreate physical objects over large distances in a form of teleportation. Dr. Mark Kasevich, a physicist at Stanford University, and his colleagues have shown it is possible to put two clouds of rubidium atoms into a quantum state known as a superposition. This normally occurs in subatomic particles where they can exist in two spin states at once, up and down. Superposition in atoms. In their experiment, the researchers used a technique called light pulse atom interferometry. This uses lasers to produce distinctive interference patterns to help scientists identify atoms. The researchers created a cloud of 10,000 rubidium atoms, which measured a few millimeters across, and shot it up a 30-foot high, 9-meter, chamber using lasers. When the cloud, known as a Bose-Einstein condensate, reached the top of the chamber, it adopted two different states for a few seconds before falling back down. In particular, its wave function split and the two states took up positions 21 inches, 54 centimeters, apart. It remained in this superposition for about a second and the lasers turned the two states back into one when it reached the bottom. By studying when these two states of atoms arrived at the bottom, the researchers found the atoms seemingly fall from two different heights, separated by half a meter. Previous attempts to do this had only managed to separate the atomic superpositions by a few centimeters. Quantum entanglement. In quantum physics, entangled particles remain connected so that actions performed by one affects the behavior of the other, even if they are separated by huge distances. This means if you measure, up for the spin of one photon from an entangled pair, the spin of the other, measured an instant later, will be down, even if the two are on opposite sides of the world. Entanglement takes place when a part of particles interact physically. For instance, a laser beam fired through a certain type of crystal can cause individual light particles to be split into pairs of entangled photons. The theory that so riled Einstein is also referred to as spooky action at a distance. Einstein wasn't happy with theory, because it suggested that information could travel faster than light.